Here are our equations for a parabola when it has a vertex at 0, 0. And so as you can see, we have 4 equations down here, which are also listed right here. And so when we are picking which of these 4 formulas to use, we are wanting to know, how is this parabola opening? Is it opening up to the right, to the left? Is it opening up, or is it opening down? When it is opening up to the right, we will use y squared equals 4ax. When it is opening up to the left, we'll use y squared equals negative 4ax. So the only difference between here is this one has a positive 4 and this one has a negative 4. If it is opening up, then we use y squared equals 4 ay, and if it's opening down, we use x squared equals negative 4ay. So again, the difference between the two is up is a positive 4 and down is a negative 4. So how do you tell from the equation if it's opening up or down or left or right? When it is opening up, or sorry, to the left or to the right, those are your y squareds. And when it is opening up or down, those are your x squareds. We're used to x squared, right? Y equals x squared is this right here. So x squareds open up or down, y squareds equal or open up to the left or to the right. So you only have one squared variable here, either x or y. With circles, ellipses, and parabolas, both x and y are squared. So that's how you can tell the difference between the two, that these only have one squared variable. Now, the other big thing to focus on here is the focus. Your focus in previous lessons have had C be the variable for your focus. Here, you only have one variable, and that's all A. And so your focus is represented by A this time, not C. And then your vertex here doesn't have, in this case, doesn't have a variable, but technically the vertex is HK. When you look at your next page here, you have things in parentheses, and that's going to let you know that the vertex is at the point HK. Usually we put those for centers, but now it's vertex is HK. So a little bit of a difference as far as how we label our points, what variables we're giving are different parts, okay? And then the other thing that we need to write on here is we have something we need to focus on, and that's specifically this 4a portion, which every equation here has that 4a in it. So 4a and the absolute value of negative 4a. These equal the length of what is called the lattice rectum. Okay. And a lot of times I don't want to write that out every time, so we'll label that as LR. And what that lattice rectum represents are the points that go through the focus. Okay, and that's always going to be that length of that 4a. So if I look at this first one here, going through this focus, this right here would be my lattice rectum. And that lattice rectum equals whatever that 4a portion is. That tells you the length of it. And here is your latus rectum. If that graph was a little bit bigger, latus rectum and latus rectum. And all of those have the length of 4A. So when you graph these, it's going to specifically want these 2 points to tell us how wide this parabola is going to be. So here we go. Find the equation of a parabola with a vertex at 0, 0, and the focus at -2, 0. So 0, 0, and -2, 0. So I'm actually going to come back up because I missed a whole portion of this, and that is my directrix. My directrix is always going to be behind my parabola. So when this opens up to the right, it's over here to the left. When this parabola opens up to the left, it's over here on the right. When it opens up, it's going to be down, and when it opens up to the down, it's going to be above it. Those are always equal distance. So whatever this length is from vertex to focus, it is going to be the same as the distance between the vertex and the directrix line. Those are equivalent lengths. So if my focus is at -2, 0, and my vertex is at 0, I'm going to go 2 units the other way, and my directrix right here is right here. And so this is at x equals 2. Because my focus is 2 units away, then I know my directrix is 2 more units away, going the opposite direction. So now I have to figure out which of these 4 formulas that I need. Which one has a focus, then the center, then the directrix over here to the very right. And that looks like this one right here. So I am using the equation of y squared equals -4ax. The only thing I need for my equation is my a. And a is the distance between the vertex and the focus and the vertex and the directrix. That distance is 2. So all I need to do is plug in a 2 for this a. So I've got -4 times 2 times x. That simplifies to y squared equals -8x. So that is my equation. Now to graph this equation, I need my latus rectum points. And remember that latus rectum goes through that focus. So the latus rectum, that length is what this 4a portion is. And in this case, it's this 8. So all I'm going to do, and I don't care that it's -8, right? It's either 4a or the absolute value of -4a. So either way, it's always positive. I'm going to take this 8 and I'm going to divide it into 2, which is going to give me 4. The reason I divide it into 2 is because I know this entire length needs to be 8. So this will tell me what the halfway mark is. So I can go 2 units up. That's a latus rectum point. And I can go 2 units down for my other one. This here tells me my shape. So I'll go from vertex through that latus rectum. And there is my wonky parabola. And a lot of times it's going to actually want the point. So that's -2, 4. And this one is -2, -4. And so now that entire length is 1, 2, 3, 4, 5, 6, 7, 8, which is what it should be. I'm dividing it in half so I know how many to go up, how many to go down, because this focus is in the middle of that. Okay, let's continue. We're gonna have 3 more examples. We're gonna get 1 example of each, I believe. So here we are analyzing this equation. So when I am analyzing this equation, let's just figure out which of these 4 graphs that I am going to have. Which graph am I going to have? Is this going to open up to the right, to the left, up, or down based on y squared equals 4x? Okay, you know it's got to be one of these 2 because it has the y squared, and because it's a positive 4x, that means it's going to be this one here. So I know what this parabola is going to open to the right. Okay. So my vertex, I know my vertex is at 0, 0, because it's not x minus h and it's not y minus k yet. It is just x and it is just y. And I'm actually going to do something with this problem, if you don't mind. I don't know. I actually want to change this problem. Let's make this one y squared equals 12x, please. Still the same equation though, because it's still y squared and it's still a positive in front of that x. Okay. So my vertex is at 0, 0. So I need focus and I need my directrix. If this equation is usually y squared equals 4/8x, this tells me that 4a and 12 are equivalent to each other. So I will set 4a equal to 12, divide by 4, and this tells me that my a is 3. So when I come over here to graph, I've got the center at 0, 0, and I know my a is 3, so I'm going to go 3 over here for my focus, because my focus is always in the middle. And then I'll go 3 in the opposite direction, 1, 2, 3. Here is my directrix. So my focus, this ordered pair, is 3, 0, and my directrix is the line x equals -3. So now I'll graph, and we will graph by finding our lattice rectum. You always take whatever this 4a portion is. Again, in this case, it's 12. You're going to take it and divide it by 2, and we get 6. So from this focus, I'm going to go up 6 and down 6, which makes me a little bit off the graph, but that's okay. And there is the width of my parabola. These points are 3, 6, and 3, -6, but that entire lattice rectum length is still at 12. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That whole length right there is 12. I'm taking it, dividing it by 2. So I know from here how many to go up, how many to go down to get the total amount of 12. Okay, we're going to analyze this equation. So take a second to look at these graphs. Is this going to open up to the left, to the right, up or down? Okay, that's this one here. You've got your x squared, but what's different is that this one is negative. This one would be positive. This one's negative. So this is x squared equals negative 4ay, which tells me it's going to open down. Okay, so my vertex is 0, 0. We need focus and directrix, which are equal distance from the center of 0, 0. Okay, again, when I look at those equations side by side or stacked on top of each other, that negative 4a and negative 8, those are both in front of my y. So those are equivalent to each other. So I've got negative 4 equals negative 8. I'll divide by negative 4. And a equals 2. So the focus is always in the middle of your parabola. So that tells me I'm going to go 2 units down for my focus. And then I'll go 2 units up to make my directrix. So this equation is x equals 2. Nope, that's not x equals 2. X equals 2 is right here. That's crossing your y-axis at 2. So let's go y equals 2. And then the focus, what's this ordered pair? That is 0, negative 2. So now let's graph. And we graph by making that lattice rectum. Lattice rectum is what's right out here in front. And remember, it doesn't matter what the sign is. It's either the 4a or the absolute value of negative 4a, which is still positive. So I don't care that it's negative 8. I'm just looking at that number of 8. So 8 divided by 2 is 4. So from here, we'll go 1, 2, 3, 4. And 1, 2, 3, 4. So here is my parabola. And now that lattice rectum is 1, 2, 3, 4, 5, 6, 7, 8 units wide right here. This is negative 4, negative 2, and this point here is 4, negative 2. And then lastly, find the equation of the parabola with the focus at 0, 3. And the directrix at y equals negative 3. Okay, it doesn't tell me where my center or where my vertex is, but I do know the vertex is in between, in the middle of these two. So that's 1, 2, 3, 1, 2, 3. My vertex is right here at the center. When I look at these 4 examples, which one has a focus on top, the vertex below it, and then the directrix below even it? Focus on top, vertex below it, directrix at the very bottom. That's this one right here. This one's opening up. So I'm using the equation x squared equals 4ay. The only thing I need here is my A. And what is my A? It's 1, 2, 3, 1, 2, 3. A equals 3. So we've got x squared equals 4 times 3y. So x squared equals 12y. That is my equation. So then now we need to graph the equation, and we'll do that by finding that lattice rectum. You're always taking what's in front of your non-squared term and dividing it by 2, in this case 6. So from my focus, I'm going to go 6 to the right and 6 to the left. And here is my very wide parabola. This point is negative 6, 3, and this one is 6, 3. And now that lattice rectum is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units across. I'm again dividing by 2. So from that focus, I know how many to go in each direction.